Good morning. In this video, I'm going to help you prepare for your quadratics test. I'm going to go through questions 1 through 9, so the first page off your review. So in the first question, it's asking us for the axis of symmetry, and we're given an equation in standard form. Because I have an equation, what I want to do is go ahead and graph this. So I'm going to go under graphs, and I only need to type what is after the equal sign. So once I graph it, I can see my parabola. It's opening upwards, which makes sense because my A value is positive. To get to the axis of symmetry, I'm going to go to Menu, Analyze Graph, which is option 6, and then Analyze Conics, option 8, and then here I'll see my axis of symmetry. It's option 4. So when I go there, nothing pops up on my screen. I have to use the mouse pad and click on my graph, and then my axis of symmetry will stay. Not only can I see it splitting the parabola in half, but I also get the equation. When you have this question on your test, you must make sure that you have an x equals, and then that -3. Okay? By the way, that x value, -3, is the x value of your vertex. Speaking of vertex, if we come take a look at question 2, what is the vertex? My vertex is going to be that turning point, the very, very bottom or top. So this right here is my vertex. And remember, when you write your vertex, it's the x value followed by the y value. So I look up at my coordinate plane and I see I have my x value as a +1. And I come over to the left and I see my y value is a -8. So my vertex has the point 1, -8. The zeros, that's our x-intercept, the roots, the solutions. And on this graph, I can see it's -1 and +3. So I have two choices. I can write it as -1, 0 and 3, 0, two ordered pairs, or I can use the brace indicating the set of -1 and -3. Okay, 3, very similar. Once again, I have another graph. I'm asked to identify my vertex. My vertex is that turning point, the very top or very bottom. So once again, coordinate point, my x value, I look down and I see it's 2, and my y value is a +1. My axis of symmetry is that vertical line that goes right through the middle. Always starts off with an x equal, and it's the x value of the vertex, and I can see that is where I would cross on the x-axis as well. For question 4, I want to know if these represent a quadratic. And so 2 ways that I showed you guys in class. One is going to be the differences. So from 12 to 3, this is a decrease of 9. 3 to 0 is a decrease of 3. Here, we're increasing by 3 and increasing by 9. Now, these values are different, which means it's not linear, but I have to do this again to determine if it's quadratic. It's the second set of differences. From -9 to -3, that is an increase of 6. -3 to +3 is another increase of 6. 3 to 9, increase of 6. So since these are all the same, our answer would be yes, because the second set of differences are the same. Okay? If you don't like doing this, another way to go about determining if you have a quadratic is going to be to use the calculator under Lists and Spreadsheets. So here I go to option 4. Remember, you have to label that first column X because it's going to hold all of your X values. So just quickly type those in, and I arrow over. Want to label the B Y because it's going to hold all of my Y values. And then here, make sure you type them in carefully so we get correct information. Okay. Now I'm going to do Control Dot to add a page. We go to Add Calculator. Then from here we press Menu, I want statistics, it's option 6. Then I want, if I remember, stat calculations. And I want quadratics, so that's going to be option 6. Here we got to input our X and our Y column from our list and spreadsheets table. And then it tells me, all I want to know is the A value. Do I have a value for A that's not 0? And my answer is yes. Because my A value is 1, that means I have 1 times X squared. Is that X squared? I have an X squared, therefore I have a quadratic. Okay. 5, here's another one. We're being asked to identify the vertex. Our vertex, that turning point, has where is the maximum or the minimum, which we're also going to identify. So here, I'm going to go ahead and choose to graph this so I can quickly see my parabola and identify its vertex. So here's graph. Now, I don't see, at the moment, I don't see my graph at all. Okay, make sure I typed it in right. -2, yep. Okay, so if I don't see this, if I don't see my, oh man, I deleted it. Which sometimes, I know sometimes when you guys are taking your test, you're like, miss, my graph, I don't see it. Okay, that's okay. That doesn't mean it's not there. It's there. So 2 things that you can do. 1, you can do menu 5-1 to trace it, and it will automatically zoom to find your graph. You can also do Control T and look at the table. Or you can also do your menu and go to view. And this is not view. Go to zoom. And here you can zoom out if you need to. Okay. Since I already found my y-intercept, which also happens to be my vertex, I can see. I can confirm if I want to be 100% sure, which is always a good idea, especially when you're taking a test. I can go to Analyze Graph, Analyze again, and then Vertices. And then once again, I'll click on my graph. And very faintly, I don't know if you can see. See if I can move it. Okay. I still get that same ordered pair as the y-intercept. Okay. So, didn't take very long to double check, which is, like I said, always a good idea, especially when you're taking a test. All right, skipping on over to number 6. Let's make sure you get a good view here. All right, so here on number 6, what is the y-intercept? So be careful, because sometimes, whether it be on my test or the STAR test, whatever, read the question carefully. Don't start assuming that you know what's being asked. This is asking specifically for the y-intercept, so it's where it crosses the y-axis. And I see that is 2. So as an ordered pair, it is 0, 2, because my x value is 0, where the y, my y-intercept, is 2. Okay. Number 7, identifying the domain and range. Domain, x values, x goes left to right. Now, from the left to right, because this is a continuous function and there are no restrictions, that means even though I don't see it, these are going to keep on going, the graph is going to keep on going forever and ever in the direction. So I have arrow on the left, arrow on the right. That means it's everything. So for our domain, it's going to be all real numbers. And yes, you can also put the symbol for all real numbers. Okay. For the domain, is taking care of all real numbers. The range is a little different. The range is specifically targeting those y values. This is where we need to know, do we have a maximum or a minimum? Here, this is the lowest point, therefore it is a minimum. This is my lowest value. Everything is going to be greater than that. Therefore, my range is y is greater than or equal to, because I want to include the value, and this would be -5. Or I can also see on the vertex, -5. If you happen to have the domain and range and you don't have a picture, it's okay. You can create your own by using the calculator. So once again, I go to calculator. I want the picture, so I'm going to go ahead and graph this. So I have f of x, which is my y, x squared minus 8, enter. Here I do see my parabola. I can see it's opening upwards, which makes sense because my x squared is positive. From left to right, it's going to keep on going on forever and ever in those directions. So one more time, I have my domain. It's going to be all real numbers. But my range is a little different. My range, my y values, greater than because it's opening upwards. And I need to know, what is that minimum value? Two things. You can trace it or you can find the vertex. And I'm going to go ahead and find the vertex. So I'm going to go Menu, Analyze, Analyze again. Vertices is my option 2. And I'm going to click on my graph so I can see my coordinate point. And, where'd it go? Click on my graph. And I can see very faintly, I don't know why it's not saying, 0, -8. So that -8 is my lowest, my minimum value, my y value. So I'm writing it in my range. All right, and the last question in this portion of the video, which represents the quadratic parent function. For it to be quadratic, it has to have the x squared. That is the minimum requirement. If you have that, you have a quadratic. Therefore, that's all we need, and it is going to be our quadratic parent function. This one has no x squared. It's not even quadratic. Likewise with option D. B, this is quadratic, but this is our general standard form where your A, B, and C values are representing an actual number. So either a coefficient or a constant. All right, good luck. Let me know if you have any questions.